Thanks for joining me. We're going to look at solving a quadratic equation by completing the square. This is the first example of two that I'll do, two short videos. And example 1 has a leading coefficient of an understood 1, which makes it a little simpler than example 2. Okay, I've grabbed the steps for completing the square from a textbook by Ratty and McWaters, published by Brooks and Cole. And I'll try to follow the steps as they've outlined them. Let me get this here. Step 1, rearrange the equation so that the terms x squared and x are on the left side and the constant term is on the right hand side. If the leading coefficient isn't 1, then make the coefficient of x squared equal to 1 by dividing both sides of the equation by the original coefficient. Now here's step 3. When I talk about the convenient number that we're going to add to both sides, that convenient number is created as follows. That convenient number is the square of 1/2 the coefficient of x. And we add that convenient number to both sides of the equation. So step 3 is kind of the magic, where it feels like you're pulling a number out of the thin air, but it's really a convenient number. We do step 3 so that we can factor the left-hand side into two identical factors, x plus k, and rewrite it as x plus k squared. You'll see that in the example. The right-hand side is a number d, and it'll be a positive number, and well, if there's real roots, it'll be positive. We can take the square root of both sides. Of course, we'll get two roots, the plus and the minus, and then we solve the two linear equations, resulting in step 5. All right, let's have at it. Let's solve this equation by completing the square. Okay, I believe step 1 was to move this constant term to the right. So I'll leave the x terms on the left-hand side of the equation, and I'll subtract 7 from both sides of the equation. Now step 2, if this leading coefficient was anything other than an understood 1, we would divide both sides by the leading coefficient. But there's no need to divide. Instead, we're going to make the left-hand side a perfect square trinomial by adding a convenient number. And that convenient number is 1/2 of the -6 squared. 1/2 of -6 is positive 9. And if we add 9 to the left-hand side of the equation, we must add 9 to the right-hand side of the equation to counteract. Now look at this left-hand side. This factors into x minus 3 times x minus 3. And that's why the 9 was convenient. We get x minus 3, the quantity squared, equals to positive 2. Okay. Now to get x by itself, we do need to take the square root of both sides. But when we use this technique to solve equations, we need to remember that we get two possible roots, the plus and the minus. So simplifying, the difference x minus 3 equals plus or minus the square root of 2. So either x minus 3 is the positive square root of 2, or x minus 3 is the negative square root of 2. And isolating x, we get two solutions. Two irrational, oops, excuse me, that's a minus. Minus two irrational solutions. This is 3 plus about 1.4, and this is 3 minus about 1.4. And we could find the decimal equivalents, but I think we'll stop there. And maybe label these x1 and x2, as you can also interpret those solutions as the x-intercepts of the function on the left-hand side. Just FYI, I'm going to create a Maple video, which means I can rework this problem using some software called Maple and demonstrate the graph of this quadratic function here on the left and I can show completing the square and some numerical results. Thank you for your attention.